Welcome students. In this video we're going to look at extrema of the following function. G of x is equal to 6x squared over x minus 2 in the closed interval -2, 1. So first things first, we need to find the derivative of g prime of x. So doing the quotient rule, we're gonna get that the derivative, I already did this derivative for you, so that's gonna be 6x. So let me write a little bit. So let's set it up, okay? So it's gonna be 12x x minus 2 and then minus 6x squared all over x minus 2 squared. So if you simplify this, you're gonna get the derivative is gonna equal to 6x x minus 4 over x minus 2 squared. Notice the critical points here is when x equals 2, but 2 is out of the closed interval, so we don't worry about it. And also if you plug in 0 here or 4, you're gonna get 0, but the only one that is gonna work out is when x equals 0. So that's the only one. That's the only critical point. And then when x equals 4, 4 minus 4 is 0. But see, 4 is out of the interval. So we're just gonna do left endpoint. Left is gonna be when x equals -2. And then the critical point, which is critical which is when x equals 0. And then the right when x equals 1. So g of -2 is gonna equal to, if we're plugging -2 here, I'm gonna get -6. If I plug in x equals 0, I'm gonna get 0. And if I plug in 1, so I'm gonna get -6. So looking at the value -6 is less than or equal to all the values, so it's gonna be a minimum. So this one is also a minimum. And then the critical point, when the derivative is equal to 0, that's gonna be your max. So notice there is a theorem that says that relative extrema only occurs at critical points. So that's it, this one here, max at critical points. Alright, so first of all, we get a function, we get a closed interval, we find the derivative, we plug in our left and right endpoints, and we plug in our critical points, then we find the minimum and max. And that's all we have to do for this type of problem. Thank you very much, students. Bye bye.